Hi again. I hope I'm not boring like person as well. But this one is actually more interesting because it has at least almost 10 innovations that we do at Sui. So it's the future of cryptography here in our blockchain, and you will also see some of these things will be the standard in the industry. So very quickly, the agenda will include from zero knowledge proof to how we can go to internetless transactions. And as you can see, I have like many things being covered, from randomness to time capsules to how you can NFC everything and all this stuff. So TLDR, you will realize that in the next few months, we will have some very, very unique features in the space of zero knowledge proofs. Randomness, you've seen a presentation about randomness. And this randomness will offer some of the things. For example, I have some capsules, some secret NFTs, and then eventually the last one where it says physics waves, blah, blah, blah. This is the internetless. Many people are asking us, what is internetless? Today you will realize exactly what it is. So first topic, right? You've all seen ZK login and what someone can use at the moment without having a password to be able to have an account. Some of the problems we're solving, though, is it can also be used as a KYC element with some like good privacy. And in this particular situation, you might have a campaign that you say, I only want people to onboard that are of gmail.com, or they are in Japan, or they are in Brazil, or anything that is like a prefix that it's not like public on chain, but you can only see the suffix of the particular email account. So your addresses, if you want to prove something either on chain or off chain, with zero knowledge proof, you can prove something about your identity, but obviously most of the people would just pick the suffix. We will add more providers. At the moment, you see Google and Twitch. More are coming, and I will tell you that most of the like big OpenID providers, like Apple, Facebook, and all of this stuff, are coming to Sui. And we will enable even custom like participation from anything that you want to have on your own game, DeFi, and so on. And finally, it's already on DevNet at the moment, and very soon you will have multi-sig. And the multi-sig is important because some people want to have recovery, or in some situations you want to say, I log in with Google, or I log in with Facebook, or I log in with Google and I have a mnemonic. I mean, by the time for some reason I'm losing my email, I still have in the vault some mnemonic that I will recover my account. So all of these are very new, and you will see some new zero knowledge proofs coming into the Sui blockchain. Very interesting stuff. Many people are complaining, what do I own if everyone can download my art NFT? And we have a solution for this. With zero knowledge proofs, you will be able to have a snapshot, a sample of your like objects. Imagine this can be a book in Amazon where you have a preview, but only when you buy it, you can see the full content. You can sell software, a freemium software, where you have some functionality, but only if you pay, you will see all of it. And now we are protecting also the second sellers and the second buyers. And all of these via zero knowledge proofs. And I will explain, although the system is quite complicated internally, we will manage to do it like very friendly for the users. And here is how it will work, pretty much. So imagine you are now like a seller. You can pick your NFT, and imagine this can be book, software, whatever you want, but in this particular, it's an art image. You define exactly what you want to be public for people to buy it, like to lure them to go and buy it. Nobody can see what is on the other pixels, but people can see exactly like some preview of the NFT. And then the buyer will just go and look at this thing, and when they buy it, they will see the full image. Only the buyer will manage to do it, right? This is very important. So now, we have the randomness, which is another thing that is very interesting in Sui. I don't believe there is any other blockchain having 4 ways of doing randomness. And I will explain what I mean. So here I have some dice. I will throw it to someone, like whoever catches it. It's OK. So something that we will do is, how do you do randomness on chain if you don't have anything like as a tool, right? You know what is the easiest way to have randomness on chain and play blackjack, having like a coin flip or anything? So Christie, right? OK. So I will pick a number like in my bag, and you will do the same. Don't show me the number. And I will do a guess that the sum of our dice is an odd or even number, right? So nobody knows the number. We commit it, and this is like pretty much the VRFs that you see here. We're committing into something, and then eventually we both reveal, and I say odd, the sum is odd. I have 2. What do we have? 3. It's an odd number, and I won, right, in this particular situation. If you see, whatever you have the sum here is practically 50-50 percentage if I will find it or not, right? And if we can commit and then we reveal, this is fine. What is the problem here? Christy might have refused to reveal her vote, and nobody knows if I won or I lost. And this is one of the problems that they have. You can support it now. For example, if you're a casino, you can do the same, and you can have a time lock. You say if somebody doesn't reveal their own coin flip or whatever the number is, then they will lose the game, right? And this is exactly how the randomness works in some particular applications today. There is another thing that you can do. You have VDFs. VDFs means you just put some random number there, then there is operations happening, and then eventually it will take 1 day for this operation, even in the fastest CPU, to show the output. And imagine here you can have a randomness with the weather as being the input, or the stock market, the closing prices of the stock market in the second decimal digit. And nobody can predict it, right? Tomorrow, and then we apply a hash for 1 day, and the output is the lottery. But we have Sui native randomness. You've all seen how it is in Sui. So in your smart contract, we will just say .rng, and then eventually you will have your own randomness on chain. So in Q3, we're going to have passkeys. All of the new devices, all of the new operators are now supporting some passwords inside your phone, which is shared between your devices, and you're going to see it in Sui as well. And as I said before, we have multi-sig, right? So you can say a passkey or ZK login, a passkey or a mnemonic, a passkey with this device or my wife's device. So you can do many interesting stuff with Sui. There is an SIP already, and we're going to do it in the next few months. Time capsules. Time capsule is a very interesting feature, right? And it has all of these applications that you can see. It was quite an experience for me to travel to Paris because I have a time capsule here, as you can see. So what we will do, I will give it to someone, and then in a piece of paper you can write down whatever you want. I will hide it. This one will probably go to Dubai. It will be hidden somewhere, and in 2 years I will open it again. But you can do with software in Sui as well. And what I will do is I will dig it somewhere in Dubai, and then with software, you will see how in 2 years exactly, the same day, 11th of April, it will be open. I give it to the organizers here. If you have anything, like any piece of paper, just unscrew it and put it inside, and I will open it in 2 years. So you see all of the good applications, right, we can have with time capsules. It's an insane protocol. We can support it, and the randomness beacon plays a role here. The other thing is we have Capsa Passes. What it means is you are connecting your wallet, you are going to get a passport, an NFT that you passed the Capsa challenge, and because of composability, you can go and interact with a smart contract, and it will approve you if you have this passport. Because Sui is object-centric, when you get a passport, you can use it in other smart contracts that they can understand what this means. And imagine this as a KYC element, right? Because now we're issuing Capsa Passes, but it might be a KYC pass. And all of the contracts that they trust this particular issuer, they can accept you as you are not being a bot. A very interesting stuff here is the UI gateway. Some people don't want the smart contract invocation to happen from the command line from a bot. Now you force the user to go through the UI. And now you know exactly how they managed to call your smart contract. The other thing is we are going to NFC everything. And when I'm saying that is you've already seen a few cards that you have like in this room, like yesterday and today. You can use eventually your wallet to tap, like to actually top up a card, and this card is giving you some access. Imagine you're going to the restaurant of tomorrow. There are some POS systems, and they accept this card instead of the Visa and MasterCard card. But there is another interesting thing that I realized personally. It can be a 2FA, the cheapest 2FA you can have, $0.3. You can get a card with an NFC. This is like a reusable card. You can put part of your key there, and you're creating a multi-sig. So you say 2 out of 2. So you need your mnemonic or ZK login, but you also need this card. And you can have multiple copies of this card. Even if you lose it, it's a 2 out of 2. Someone needs to break your Gmail as well. Something that I see is you can play games. Imagine Pokemon and you stack up the cards, and then eventually you say, if you see this card, someone manages to accumulate these 3 cards, they get an extra power on the game. So it's an amazing experience now. We will see like hardware like throwing around Sui. Treasure hunting, of course, is one of the best applications. I like it very much. And yeah, this is amazing. Now that I mentioned treasure hunting, so something I have here, oh my gosh, this is precious. Now, for this, they stopped me at the airport and they interrogate me. I was almost naked in San Francisco. But here I have a time capsule. Can someone bring it? I don't want to make noise again. If you find the password, there is 100 Sui here. This is very interesting. You can pass it around. Whoever finds it, they get both this capsule and the money inside it. So, SuiLink, what is SuiLink? We managed to connect Sui and Ethereum in Sui. So what you will realize, you have a campaign, but you don't have Sui users yet, but you have Ethereum users. Go do your data analytics. You go to the Ethereum blockchain, you're downloading all of the active accounts, and then you say, okay, if you prove to me that you are the owner of this Ethereum address, but in Sui, I'm going to issue you something, to airdrop you something in the Sui network. So this is exactly what's happening here. So you prove with your MetaMask that you are the owner of this, or any other wallet, the owner of this Ethereum address, and you're getting issued, what did we say before with the CAPTCHA? You get a passport. I get a passport that this is my Ethereum address, and there is a link between the Ethereum address and the Sui address. And now I'm airdropping to the Ethereum address, but in Sui. And this is crazy because now Sui has the great benefit of all of the cryptography of all of the other chains is available in Sui, but not vice versa, which means that eventually you will see someone building the same thing for Solana coming to Sui, or you will see all of the other blockchains being able to airdrop to their users on Sui, though. I mean, if you have a wallet or you have a campaign, this is an amazing thing. We're calling it SuiLink. Now, what I realized, there is a partner, and this partner is using the zero-knowledge proofs in Sui to have KYC statements. It's not us here, right? It's another protocol. It's called the Reclaim protocol. But what they do is they have the ability now on their blockchain to be able to verify some statements. And this is amazing because you can go to a website, you are using their application. For example, you are opening whatever is a USA credit score. Your Experian credit score is whatever it is here. And then the protocol is able to extract from the TLS session that you have the number and prove it on-chain or prove it off-chain using the Sui tools. This is amazing because for the first time, you can connect the Web 2 credentials with Web 3. And we're very fortunate to have one of the first implementers and researchers coming from Cornell, Deepak, who worked in a previous protocol, and now we're bringing this into Sui. I'm telling you that the research team we have here, I used to work at Facebook. Facebook was probably the most funded company around the research team around the world for Web 3. And half of this team is coming now to Mysten Labs and Sui. And I'm very grateful all of these people are working for Sui today. Path to Internetless. So what is Internetless? We can do anything from all of this list that you see here in order to transmit transactions without having access to the internet. And what does it mean I don't have access to the internet? I don't have a Wi-Fi available for me, or I don't have 5G or 4G. And imagine situations where you are in the mountain, you're hiking, and you want to have even a heartbeat about your wallet. Am I still, do I still have the balance I have? Can I submit something that I'm still alive? Can I see if my balance has been updated? Can I also submit a transaction because I found someone selling, soft drinks and everything in the mountain, but there is no internet, I cannot pay? Or I land in Dubai and I don't have data, or I ran out of data. I cannot even do anything. Or there is an earthquake, there is a flood, nothing works in the area. What do you do here? Right? There are many, or even the low signal. In many situations, including this event sometimes, you might not find internet access. But there are many situations to simulate the internet using all of these technologies. And what we did is we did both SMS, and as you can see here, I have some demo. We also did long range wavelengths communication between hops of people who their phone is a relayer. And there is a huge advantage of doing this in Sui compared to anything else. What is this? Two things. We have sponsored transactions. If someone is helping you, maybe they can also sponsor your transaction if you don't have money, but we also have programmable transactions. If someone is helping you to relay the message, you can pay them something in your transaction, so you can eventually find some access to the gateway of an internet, right? And we also realize that what we can do is we can have eSIMs. Now your mobile phones can get an electronic eSIM where it's only connecting to the blockchain, nothing else. You cannot stream, you cannot do anything, but transactions, you can do it. So even if you don't have data and you have this eSIM, which will be super cheap, then eventually you can have access. The other thing is we're working on some very interesting stuff around using enclaves, like secure boxes, where in practice, you, even as an owner, you cannot go inside it and steal the private key from there. And imagine, if you cannot steal the private, you can just give away this chip to someone else, and it's like transferring money to someone else. And there is a zero RTT mini channels, which is very interesting. We have intern this year. He will work on this particular protocol. Zero RTT literally means you don't go through consensus at all. Zero. How does it work? We're creating mini channels. We have the cryptography to lock money there. Imagine you're playing blackjack, and we have the randomness, as I said before, with the game that I played with Christy here, right? So what we can do is we lock the money there, both of us, and then we play a gambling game offline. And with zero knowledge proofs and fraud proofs, we can, after we finish the game, we can return back to the internet. But imagine you go to the casino, you touch your phone there is no communication, you don't even have internet after you lock the money, and then you can play offline completely, even slot machines, right? I mean, you don't wait at all, zero. So this will happen in Sui, and this is possible only because of the cryptography. Now, let's see what we did with SMS. With SMS, actually, it will be a backup to your main network. So eventually, you're going to start sending a transaction. You cannot send a transaction. So you say, OK, let's fail over to using SMS. And this SMS is sending a compressed order into some SMS operator, whoever is this. And then eventually, the full nodes will have an SMS web point, right? A webhook proxy. So they will receive the SMS, and they know what to do with that. But in practice, the main interesting stuff is we can compress a transaction in all of this process, and the smart here endpoint can create the BCS and submit it to the blockchain itself. As you can see, we can, if it's very smart, and even if you send like the very first digits of your object, you don't need to submit all of your object, like the big objects that we see in cryptography. The smart proxy will know exactly what it is, and then they can form the transaction again. You are signing over the full data, but you don't send the full data, which now means you can feed it in an SMS. That's the beauty of using objects as well. So we have all of this stuff. Maybe you can even send the signature. 0 bytes. If it's super smart, it will even know what you're signing over. Imagine for very basic stuff like, I want to pay my Netflix, right? And I know it's whatever is the price, $11.99 or something. I don't need to send anything. The proxy can retry and see what you signed. And we have an example of this. No Wi-Fi, no mobile data. Eventually, this is a very like a sample wallet. You will see the account on the left side. So you're copying the mnemonic, because we're going to use this like sample wallet. This is an SMS wallet now. So here, you're getting the address, and you see it's matching. Like it's the same mnemonic in both wallets, but this is an SMS wallet. So I'm going to pick a receiver address. As you can see, I'm SMSing Sui now. Let's do, this is a mainnet transaction. Message sent, as you can see, is super quick. And then eventually, let's wait and see, 987 and up there, 0.5. Wow, there is an SMS. As you can see, like your phone is like feeding the application directly. And we will see 985 will drop and 0.5. OK, we receive the transaction digest, 0.6, 975, 77. So it's really working, right? It's super great that this is possible just by falling back to SMS. So now something that we can do with this stuff. We wrote a paper, and if you see one of the authors is a former CIO of BlackRock, Peter Knez. And there is also, like the third author here, apart from like this is a collaboration with Stanford, The third author is like pretty much the guy who created Qualcomm, and then eventually they even sell their company to AT&T. It's like a huge brain. And this is already accepted in a conference, and we will publish a paper very soon on ePrints. And now we're having a very interesting demo, and I will invite like our host here, who is having some very interesting devices. All of these devices are connected without, there is some internet gateway, but you will explain better. But the communication is happening with LoRa like waves.
Thank you, Kostas. So I'm Lenny Glassman, Director of Sales for VIA. We're here to essentially alleviate Kostas's anxiety of not having any data and access to his wallet. Right, that's our main purpose. We've been working on this project for about 8 years. It's been 6.5 years of R&D. This is an edge computing server. Essentially, we can run applications locally. And it's a LoRaWAN gateway, as well as a couple of other protocols, all in one box. So LoRaWAN is a long-range radio network. We're talking dozens, hundreds of kilometers if you have line of sight. But we also have Bluetooth capability, Zigbee, Wi-Fi, 4G, 5G. So if you think of the smartphone in the App Store kind of example, imagine that you have your GPS, your Bluetooth. You have all these applications. You connect to a whole bunch of different devices. What we did is we essentially created a developer portal and an app store because, to be honest, the possibilities of having Sui on physical devices anywhere in the world, with or without internet, we don't even know where the use cases can begin. There's so many of them. So it literally took 2-3 days to set up a very quick demo to have Internetless Sui. And that's the demo that we're going to share to you right now. So I have this little device. It was literally something we had at the office. It can be any device, LoRaWAN, Bluetooth, Wi-Fi, 4G, 5G, Matter, Thread. We support them all. We have Sui, a Sui wallet running locally. We can validate anything, and you can imagine any kind of device. So this is a simple, I press a button, we're going to get an update, and essentially I'm connected wirelessly. Only one of my 2 boxes actually has internet. The rest of them are wireless mesh computing, right? So we have a proprietary mesh protocol. They just communicate with or without access to internet. And normally, every 30 seconds, we have a counter. I pressed it 49 times while I was sitting here. I was a little bit nervous. And then you can imagine all kinds of sensors. The second demo that we have, temperature and humidity, right? But this is really to just inspire you guys to understand that you can bring Sui into the real world and think of any applications you want. And that's why we're proud to be co-hosting a hackathon with Sui coming up this summer. Still figuring out the details, but we'll be happy to let you guys know about that.
Amazing. Imagine applications like communicating cars. You don't need internet. You can even send a message to the car plate, right? You can think of any IoT interaction, but something else that might happen very quickly. As you can see, this device, it's this size, but most of it is the batteries, right?
Yeah, you can have tiny little devices. You can have bigger devices. It really depends on what the use case is. You can have stickers, right? It's.
And can you tell me like how big the LoRa circuit is if we wanted to embed it into a device like a phone?
So I'd say it's the LoRa chipset will be like the size of my pinky nail. So it's relatively small.
So imagine the future mobile phones have a LoRa like device here, a circuit, maybe an antenna that you need to be like a relayer as well. And all of this, like the Helium network, but now with programmable transactions and the sport source transactions and all of this compression that we do, it's running in Sui as well. The previous slide that I saw you is actually like your CEO is one of the authors there, is going, and we hope it's going to be used to save the planet. Imagine if we digitize the Earth and we can have the IoT devices communicating between them in the blockchain network, right? And now, digitized environment means that having a jaguar in the Amazon River as a digital asset is more expensive than going and killing the jaguar, right? So this is how you can eventually make sure that we will survive and we will have the rainforest in the future as well. So for me, this is one of the best applications we can imagine. It's the deep-in world of Sui. We said the gamepad that Adeniji showed you the other day, NFC cards, imagine all of these devices, and I hope a new mobile phone in the future with a LoRa device embedded will make the experience completely different. You're landing somewhere, you're even in the mountain, assuming there is a mesh network that you're like experts on this, you can have transactions in Sui. So yeah, that's all. And I'm closing this with, in my opinion, like the reality at the moment. If there was an innovation metric out there, I believe Sui is the top protocol regarding how many algorithms we're producing per week. It's literally per week. And I'm super happy we're having this team. And like, some of the people are like amazing. And I want to continue like this. This was the main reason that I left Facebook, too slow.